Download this code from codegive.com, link in the description below. Detecting dead TCP connections, heartbeats and TCP keep alive, a comprehensive guide. Dead TCP connections are a common issue in networked applications. They occur when a connection appears to be open at the TCP level but is no longer actively transmitting data or has become unresponsive due to network issues, client crashes, or server failures. These dead connections can lead to wasted resources, memory, threads, file descriptors, on the server, inaccurate connection counts, and potential hangs or timeouts for clients attempting to communicate through them. This tutorial will delve into two primary methods for detecting and handling dead TCP connections. 1. Heartbeats, application level keep alive, implementing a custom keep alive mechanism within the application protocol. 2. TCP keep alive, operating system level keep alive, leveraging the built-in TCP keep alive functionality provided by the operating system. We'll explore the advantages and disadvantages of each approach, demonstrate code examples in Python, using socket and asyncio, and discuss best practices for effectively managing dead TCP connections. Heartbeats, application level keep alive. Heartbeats involve the application sending periodic ping messages to the other end of the connection and expecting a pong response. If a response isn't received within a certain timeout period, the connection is considered dead and can be closed. Advantages ****. Application control ***. You have complete control over the frequency, format, and interpretation of the keep alive messages. This allows you to tailor the heartbeat mechanism to the specific needs of your application. Custom data heartbeat messages can carry application-specific data, such as connection health metrics or version information, beyond simply keeping the connection alive. Firewall traversal heartbeats can help maintain connections open through firewalls that might otherwise close idle connections. By sending periodic traffic, you prevent the firewall's idle timeout from triggering. Transport layer agnostic not strictly tied to TCP. Can be adapted to other protocols built on top of TCP or even other transport protocols. More robust failure detection can detect application level failures even if the TCP connection itself remains technically open. Disadvantages implementation overhead requires writing and maintaining custom code for sending and receiving heartbeat messages. Protocol complexity adds complexity to the application protocol. Increased bandwidth usage even though heartbeat messages are small, they do consume bandwidth, especially at high connection counts. This impact is usually negligible, but should be considered. Example implementation, Python, socket. Explanation ***1 constants heartbeat _interval, heartbeat _timeout, heartbeat _message, heartbeat _response. Define the key parameters for the heartbeat mechanism. 2 handle _client, con, address, ***. This function handles the communication with a single client connection. Last _received keeps track of the last time data was received from the client, either application data or a heartbeat. Send _heartbeat, a separate thread that periodically sends heartbeat messages to the client. It sleeps for heartbeat _intervals seconds. It checks if time last _received exceeds heartbeat _timeout. If it does, it assumes the client is dead, closes the connection, and terminates the thread. It sends the heartbeat _message using con.sendle. Main loop the main loop receives data from the client. If no data is received, not data, the client has disconnected. Asterisk if the received data is the heartbeat underscore message, it responds with the heartbeat underscore response and updates last underscore received. Asterisk otherwise, it processes the received data. In this example, it simply echoes it back, and updates last underscore received. 3 server, asterisk. Asterisk creates a TCP socket. Asterisk binds the socket to an address and port. Asterisk listens for incoming connections. Asterisk accepts new connections and spawns a new thread to handle each client connection using the handle underscore client function. Example client, Python, socket. How to run asterisk. 1. Save the server code as server.py and the client code as client.py. 2. Run the server, Python server.py. 3. Run one or more clients, Python client.py. You'll see the server sending heartbeats to the clients and the clients responding. By letting one of the clients sit idle without responding, simulated by the action == 3 condition, you'll observe the server detect the dead connection and close it. Example implementation, Python, Asyncio. Asyncio provides a framework for asynchronous programming, which can be beneficial for handling many concurrent connections. Asyncio explanation asterisk. Asterisk async def handle underscore client, reader, writer, asterisk handles a single client connection asynchronously using asyncio.stream_reader and asyncio.stream_writer for reading and writing data. Asterisk last underscore received and send underscore heartbeat, function similarly to the threading example but use asynchronous constructs. Asterisk async def send underscore heartbeat, an asynchronous task that periodically sends heartbeats. Await asyncio.sleep, pauses execution without blocking the event loop. Asterisk asyncio.create underscore task, send underscore heartbeat, creates a task for the heartbeat, running it concurrently with the main client handling logic. Asterisk await reader.read, 1024, asynchronously reads data from the client. Asterisk writer.write, data, and await writer.drain, asynchronously writes data back to the client and ensures the data is sent. Asterisk error handling is more robust, catching connection reset error and broken pipe error which are common in asynchronous network programming. Asterisk heartbeat underscore task.cancel, important to cancel the heartbeat task when the client connection is closed. Asterisk await writer.wait underscore closed, wait for the socket to truly be closed to avoid resource leakage or errors. Asyncio client, simplified. How to run Asyncio. 1. Save the Asyncio server code as async underscore server.py and the client code as async underscore client.py. 2. Run the server, Python async underscore server.py. 3. Run the client, Python async underscore client.py. 2. TCP keep alive, operating system level keep alive. TCP keep alive is a feature built into the TCP protocol that allows the operating system to probe idle connections to determine if they are still active. When enabled, the OS sends keep alive packets on a connection that has been idle for a certain period. If no response is received after a series of probes, the OS will close the connection. Advantages asterisk. Asterisk simplicity asterisk requires minimal application code changes. You simply enable the TCP keep alive option on the socket. Asterisk OS level asterisk handled by the operating system kernel, reducing the burden on the application. Asterisk standardized asterisk part of the TCP standard. Disadvantages asterisk. Asterisk limited configurability asterisk the keep alive interval, probe count, and timeout are typically configured at the system level, example through TCP underscore keep alive underscore time, TCP underscore keep alive underscore probes, TCP underscore keep alive underscore and flow in Linux, which may affect all TCP connections on the system. Some OSes allow per socket configuration, but it's not universal. Slow detection TCP keep alive intervals are often quite long by default, example 2 hours on Linux. This means it can take a significant amount of time to detect a dead connection. Network overhead while keep alive packets are small, they still consume network bandwidth. Passive detection only detects if the other end is completely unresponsive at the TCP level. It won't detect application-level issues or situations where the remote application is still running but not actively processing data. Firewall interference firewalls may drop or interfere with TCP keep-alive packets, preventing them from reaching the other end. Enabling TCP keep-alive, Python, socket. Explanation *1con.set sockopt, socket.sol_socket, socket.so_keep alive, 1, this line enables TCP keep alive on the connected socket. 2 platform-specific options The commented outlines show how you might adjust the TCP keep alive parameters, idle time, probe count, interval. These options are defined in the socket module as TCP_keepIdle, TCP_keeped, and TCP_keepIntVlow, respectively. Important these options are platform specific. They are available on Linux and some other Unix-like systems, but not necessarily on Windows. You should check your operating system's documentation for details. Also, changing these parameters often requires root privileges. Client, simplified, socket. Important considerations, TCP keep alive. OS configuration the default keep alive settings are often too conservative for many applications. On Linux, you can check the current settings with. You can change these settings using sysctl, but the changes may not be persistent across reboots. For persistent changes, modify the /etc/sysctl.conf file. Firewall interaction ensure that firewalls between the client and server are not blocking TCP keep alive packets. Some firewalls may have features to automatically close idle connections, which can interfere with keep alive. Keep alive time a critical value. If the TCP keep alive time is too short, it can cause unnecessary network traffic and false positives. Too long, and dead connections will persist for an unacceptable duration. Enabling TCP keep alive, Python, asyncio. Explanation, asyncio. 1 sock equals writer.get_extra_info, socket, gets the underlying socket object from the asyncio.stream writer. 2 sock.set sockopt, socket.sol_socket, socket.so_keep alive, 1, enables TCP keep alive on the socket, just like in the threading example. Client, asyncio, simplified, for TCP keep alive. 3. Choosing between heartbeats and TCP keep alive. The best approach for detecting dead TCP connections depends on the specific requirements of your application. Heartbeats choose heartbeats when you need fine-grained control over the keep alive mechanism. You want to detect application-level failures, not just TCP-level failures. You need to send additional data with the keep alive messages. You require faster detection of dead connections than TCP keep alive allows. You are concerned about firewalls interfering with TCP keep alive. TCP keep alive choose TCP keep alive when you want a simple, OS-level solution with minimal application code changes. Asterisk the default keep alive settings are acceptable for your application. Asterisk you primarily need to detect TCP level unresponsiveness. 4. Best practices for handling dead TCP connections. Asterisk implement a robust error handling. Asterisk catch exceptions like socket.error, OSERror, connection reset error, and broken pipe error to handle unexpected disconnect ions gracefully. Asterisk use timeouts. Asterisk set appropriate timeouts on requv and send calls to prevent your application from hanging indefinitely. Asterisk log disconnect ions. Asterisk log dead connection events to help diagnose network issues. Asterisk graceful shutdown. Asterisk implement a mechanism for gracefully shutting down connections, example sending a goodbye message, before closing the socket. Asterisk resource cleanup. Asterisk always release resources, sockets, threads, memory, associated with dead connections to prevent resource leaks. Use try, finally blocks to ensure cleanup even in the presence of exceptions. Asterisk consider network conditions. Asterisk adjust keep alive intervals and timeouts based on the expected network latency and reliability. Asterisk test thoroughly. Asterisk test your dead connection detection and handling mechanisms under various network conditions and failure scenarios. Asterisk avoid overly aggressive keep alives. Asterisk setting extremely short keep alive intervals can increase network traffic unnecessarily. V. Advanced considerations. Asterisk connection pooling. Asterisk using a connection pool can help mitigate the impact of dead connections by reusing existing connections when possible and creating new connections only when needed. Asterisk reconnection strategies. Asterisk implement a strategy for automatically reconnecting clients to the server after a disconnection. This may involve exponential backoff to avoid overwhelming the server. Asterisk monitoring and alerting. Asterisk monitor the number of active connections and the frequency of disconnect ions. Set up alerts to notify you when the rate of disconnect ions exceeds a threshold. Asterisk idempotent operations. Asterisk if your application performs critical operations, design them to be idempotent, i.e., safe to execute multiple times. This can help prevent data corruption in the event of a disconnection during an operation. Asterisk combination approach. Asterisk it is sometimes best to combine TCP keep alive with heartbeat. For example, TCP keep alive can detect extreme hard failures, but heartbeat is used for fine-grained management. By understanding the principles of heartbeats and TCP keep alive, and by following best practices for handling dead TCP connections, you can build more robust and reliable networked applications. Remember to tailor your approach to the specific requirements of your application and to test your implementation thoroughly.